My name is Minko Gechev. I am the Product and Developer Relations Lead for Angular at Google. And today I'm going to be presenting about something that the community has been calling the Angular Renaissance. This is a kind of like very rapid development and evolution of Angular that has been happening over the past about 18 months or so. And before we get started, I wanted to ask you, how many of you here are using Angular? Oh, right. OK, that's awesome. OK. I was thinking whether I should be making parallels with other frameworks, but it looks like we're good. Before we get started, though, I wanted to do a very quick history lesson. It's going to be mostly about Angular. And we're going to go all the way back to around 2010, 2011. And I know that this is a lot of time for the JavaScript ecosystem standards. At a certain point, there was such a rapid development of JavaScript frameworks that there was a new thing like every other month. But we're really lucky to have been having Angular for about 14 years now. So around 2011, when I was back in university back then, Angular JS was released 1.0. Any of you using Angular back then, 2011? Awesome. OK, whoa. I started using it 2012, so I'm a little behind. And people started building very complicated business applications with Angular JS. Like so complicated that it was even not designed, the framework was even not designed for them. They were very complex on the UI, so you had to have like pretty powerful and fast runtime in order to be able to deal with all the data bindings. And the source code also started growing a lot. You had to load a lot of code, so the framework just didn't scale too well. And around 2014 or so, the team announced their plans for Angular 2. And back then, it seemed like a good idea to rewrite the framework. It took a while, but in 2016, the framework was released. Yeah, and Gechev Cross, one of the original team members who was there, is right here in front of the stage. Just around that time, I moved to the Bay Area from Bulgaria. I'm originally from there, so I was at this event as well. I was super excited. I also wrote a book about Angular, so my book was going out. Unfortunately, RC5 with ng modules broke my book, but I just had a second edition. And there was a lot of excitement overall in the community. Everything was going fine until we found some opportunities to improve the runtime. And we were thinking, the framework is implemented in TypeScript, so we can just rewrite the internals. We can improve the runtime, we can improve the compiler, and we can keep the exact same public API. It shouldn't be a big deal, right? TypeScript guarantees that the public API is the same. We have our golden files. Everything is great. Well, it turned out that things are more complicated. Also, we hear that story all the time in the JavaScript ecosystem. I'm just going to go for a rewrite, because why not? Rewrites are fun. Well, it took us about 4 years to go through this rewrite, maybe 3 years, because Ivy started around 2017. And we were really confident in the quality of this rewrite. I'm going to tell you more in a little bit. But in the meantime, while we were polishing the framework, we didn't have really the bandwidth to address all the community requests that we were collecting in the meantime. That's where 2022. From 2022 onward, we have been able to finally focus on evolving the framework the way that we want it. And it is heading to a pretty good place. I'm going to tell you everything about it in a little bit. But before that, I would like to talk about this period from 2017 to 2020, why it took us actually 3 years, and why we're confident in Ivy once we released it. So Angular is developed openly on GitHub. Everything that we build it on GitHub. And everything goes through a pull request. We don't push to the main branch. We don't do any cowboy-driven development. We directly open a pull request. Everything goes through a review by many people, like a couple of people who are in the pull approve list. And every single pull request goes through a lot of different checks, 20, 30 checks or so. These are the regular end-to-end tests. We have unit tests. We have different checks to ensure that we haven't regressed in terms of size, and many more. But probably the check that triggers the most feelings in us is this one right here. Google internal tests. So let me tell you how things work. We push code to GitHub. When it gets there, we sync this code in our Google internal monorepo, which has literally billions of lines of code. And it has thousands of applications dependent on Angular. One of them is Google Cloud Console, which has about 15 million lines of code as of right now. So if anything breaks on Angular, this means that we'll immediately know, because syncing Angular in Google 3, the internal mono repo, triggers all the end-to-end tests and all the tests for all the affected targets by the change. So all the Angular projects in Google, we're going to rerun their tests. And we'll be pretty confident if we have broken anything or not. Now, I'm sure most of you here have had to deal with broken tests in your own projects, right? It's annoying. Now imagine having to deal with broken tests in someone else's project that you have never seen before, and this project has 15 million lines of code. We have a lot of pain here. Like, we experience a lot of pain on a daily basis. So the pain tolerance for the so-called caretaker on the team is pretty high. And luckily, every week we have a new caretaker so that we can distribute the pain over time. But at the same time, with this process, we guarantee really high backward compatibility. We're really sure if we have broken something, we really know about it. And this is the process we followed to release Ivy as well. We went through this process of syncing our changes again and again for many, many months. And we curated a very accurate list of a couple of breaking changes that were mostly intentional. They were just, we figured out that some things in the original runtime were not designed the way that they should be. So we decided to document them and apply automated migrations for the rest. In the meantime, we have been collecting feedback from developers in our public developer surveys, where we're getting a lot of feedback. Really grateful for it. We really have like 10 to 20,000 responses in our developer surveys, with open-ended responses where people are telling us what exactly they would like to see in the framework. We have been participating in conferences as the one today, collecting feedback from here, talking to enterprise customers, to startups. And we built a plan how we can improve Angular's performance, Angular's developer experience, and also keep everything stable and reliable. Now, we have still work to do around stability and reliability. Angular itself is pretty stable. The CLI, Angular material is pretty stable. But there is one thing. There are also a lot of third-party libraries. And making sure that you can update your project and you're not blocked by these third-party libraries not being on the latest version of Angular is another opportunity that we see for improvement. Now, let me talk a little bit about developer experience. So the moment in time that most people refer as the beginning of this Angular renaissance is the introduction of standalone components. So since most of you here, you said you're using Angular, standalone components allow you to change this code to this code, make ng modules optional, which has been great for us also to allow us to unblock many new features. So this set the foundation for a lot of the things that we develop from there. Now, there are still some boilerplate flags that we're going to move away from over time. For example, standalone is going to become true by default in the next couple of releases. But overall, the future is heading towards optional ng modules. This doesn't mean that ng modules are going away. Like your code base is using ng modules, they're going to continue working just fine. You might not be able to take advantage of the latest features. For example, deferrable views. They might not be as efficient as they would be with standalone components, but ng modules will be around. The next area that we wanted to tackle was change detection. Originally, when we were designing Angular 2, actually I was not part of the design, but when the team was designing Angular 2, I was writing my book back then. The team was really focused on making sure that the framework is really fast in terms of rendering. So they spent a lot of time making sure that the individual components render as quickly as possible. There was a lot of work into making sure that the compiler generates the so-called monomorphic code that is very efficient to execute by the JavaScript virtual machine with the so-called inline caching in there. And it is true. The individual components are really fast. The problem, though, is that change detection is still global. So every time when you empty your microtask queue of the browser, Zone.js will trigger change detection, and it is going to traverse this entire component tree. Even though the individual components are fast, you still need to traverse the whole component tree. And this could be a lot of work for large applications. Something we wanted to improve is just to make it way more well-scoped. We wanted to make sure that we check only the components that contain change that has actually changed. And this way, for instance, in this example, let's say we had state that changed inside of the item component and the details component. We'd like to perform change detection only inside of these two components instead of traversing the whole component tree. So we were thinking, well, Zone.js doesn't seem to scale the way we want it to. So what could we do? Can we explore some other paradigm for this? We looked at hooks first, because they're a very popular approach. They are used by the vast majority of JavaScript developers nowadays. But, well, they had the same problem. They, by default, require you to perform this global reconciliation. Or in Angular's case, it will be global change detection. It is still global. We looked at expanding the Angular compiler. We already had a compiler that takes your templates and translates them to these monomorphic JavaScript calls. And we were thinking, what if we introduce static dependency tracking so we can track the individual bindings in a similar way that Svelte does? And we decided that it's not a good fit for Angular just because it adds a lot of magic and a lot of extra semantics that is not very actually visible to the developer. And we also looked at at signals. And we decided to move forward with them. Now, we didn't invent signals. They have been in the JavaScript community for a while. We have been having signals in Vue for a while, Preact adopted signals. And also on the Angular signals library, we talked to Ryan Carniato from the Solid team to make sure that we learn from the lessons that he has learned in Solid over the years. With Angular signals, you just declare a signal inside of your component, where you just wrap the primitive value in a signal call. And the great property of signals is that they know in the context of which functions you have read their value. So once we compile our templates to these JavaScript functions, to JavaScript instructions, we can remember where exactly we have read the value of the title property here, so that when we perform change detection, we can detect for changes only in this particular subset of your component, only in this particular template fragment. So when you update the title property, we can go there and directly update it. We wanted to also take the reactivity one step further. We have been getting feature requests for reactive inputs for a while. People have been asking specifically for inputs as observables. We decided to not make them observables for many reasons, but we made them inputs that are signals instead. And you can wrap the signal as an observable, and you can get an observable. So you're getting, in this way, the best of both worlds. We just released input signals in developer preview in version 17.1, so you can give them a try. And in the latest release, 17.2, we released view queries as signals as well. So in this example, you have a list of to-do components. Inside of the component class, you can use a view query to find all the instances of the to-do component. And you get a collection signal. And inside of an effect, you can just track for changes. Whenever you get a new to-do item, the effect function is going to get executed. You can give this a try and let us know how it works for you. We still have time to iterate on this feature. Probably we're going to make it stable around version 19 or so this November. While we were experimenting with these signal APIs, we wanted to make sure that they're easy to use. So we worked with a bunch of developers who are not from the Angular community. We worked actually with a bunch of developers from the Angular community and outside of the Angular community to run user studies. We asked them to build a small to-do application. And we saw that the vast majority of developers, including Angular developers, they had struggled getting the right syntax for ng4 very frequently. And I don't judge them. Like this ng4, I have to look up the track by function pretty frequently as well myself. So we decided to improve the control flow because we needed the control flow advancements for signals anyway, so we could use this opportunity to improve the syntax for the control flow too. And we run on RFC. Now in the RFC, we proposed certain syntax, and the community came back to us and told us, well, we don't really love the syntax that you're proposing. Maybe you should be using this add syntax instead. And we're like, well, sure. We ran a couple of more surveys, the Angular external developer survey and the one at Google. And developers were preferring this add syntax, so we just moved forward with it. Some of the features of this new control flow that we really like are that it is still statically analyzable compared to, let's say, the control flow in JSX or TSX, which is not really statically analyzable. It is very flexible, though. But Angular's philosophy is to provide statically analyzable templates that we can optimize at build time. And also, it looks very familiar. It is JavaScript-like syntax. Another thing that we did in the meantime was to also make it way faster. So here is a screenshot from the JS framework benchmarks. I anonymized the frameworks mostly because I didn't want to start a framework war here in the middle of the conference. But you can see that Angular is performing up to 90% faster for some benchmarks compared to NG4 in the past. All right. Well, together with the reactivity and the control flow, we worked on improving our developer tooling. Good thing in Angular is that, well, it comes in as an opinionated stack, so we can make assumptions about your applications. For instance, we know that you have dependency injection, and we know how to figure out your dependency injection structure with the debugging APIs that we built into the Angular runtime. In version 17, we shipped this new feature in Angular DevTools that allows you to preview your dependency injection hierarchy together with all the dependencies of your individual components. Something that we shipped two weeks ago is also a feature that allows you to figure out your mismatches during hydration. So if your server returns an HTML that doesn't match the DOM that the client has rendered, Angular DevTools will tell you where exactly and how you can fix it. OK, enough about developer experience. Now let me talk a little bit about performance. We have been working with the Chrome Aurora team on a feature with the Angular image directive. So the Chrome team, they analyzed a lot of the websites on HTTP archive, and they figured out that loading images is one of the biggest bottlenecks for most of them. So they collaborated with multiple teams, with the Angular team. They also worked with the Nux team and with the Next team to find the best practices to load images and embed this as part of the framework. The Angular image directive introduced about 75% LCP improvement in Land's End, that is an e-commerce website. And for Virgin Media, it reduced their CLS, cumulative layout shift, with over 90%. Thank you, Gechev. Additionally, we started working on declarative lazy loading and prefetching. So this is based on the collaboration that we have been having with the Wiz framework inside of Google. You can learn more about it in the web development at Google talk that Hussein Jatin and I are giving today at around 2 p.m. But we have been working really closely with this team that is powering Google Search. They introduced the concept of resumability about 10, 12 years ago, and we are getting some inspiration from their implicit lazy loading, but making it a little bit more explicit so that it can better fit the current paradigm in Angular. It allows you to specify like part of your component tree and lazily load it so that when the user, let's say, scrolls your application or like makes certain element visible, the framework can detect this with intersection observers and download your code. I wanted to show you a very quick demo. Let me see if I'll manage to do that here. All right. I have a simple Angular application that has this very basic chat component that I can type into and get individual messages. if I open the network tab and I look at the main bundle, you'll see that the chat component is in here. It renders. But like if you have opened an e-commerce website, you probably know that maybe 99% of the time you would not really engage with this chat box at all. So it doesn't really make sense to eagerly load it when the application loads. With the new deferrable views, you can just use a defer block, specify on viewport, wrap the chat here, and specify a placeholder. This is just an element that would show while the app chat is loading. So we can just put a span, save this, and now when we go to the main component, we're going to see that the chat box is no longer here. If we expand it, we see that the chat box loads in here like automatically. Just intersection observers automatically detected that the chat box became visible and triggered loading and rendering of our chat component. So it is just literally like, I don't know, like 4 lines of code that enable this. And this API is still in developer preview, but we're expecting to make it stable in the version 18 release this summer. OK, let me go back to presenting. Build.com are using this already in production, and they saw about 50% bundle size improvement for one of their applications. This clearly very much depends on how you structure your application and what code you load. But we're thinking of taking this one step further. Now, traditionally, when you render an Angular application or like any kind of an application out there with the traditional JavaScript frameworks, you would get a response from the server with the HTML, like if you're using server-side rendering, that the browser is going to render, get the DOM tree, download all the JavaScript, and hydrate your application. And this usually works fine. Sometimes the hydration can take a while, just because if you have a lot of JavaScript, this will take a lot of time to load, a lot of time to like parse and execute. Something that we have been collaborating closely with the Wiz team on is something called partial hydration, which allows you to send a request to the server, get the rendered application, but not load any JavaScript at this point. We just have a tiny library on the page called JSAction that has one global event handler that captures events. Now, when the user engages with any of the components and triggers an event, this event is going to bubble up, just like events bubble up in JavaScript. JSAction is going to catch this event and trigger a download of the component that needs to handle this interaction. And it is going to hydrate only this particular part of your component tree. This is going to significantly reduce your JavaScript bundle size. And this is something that we're planning to ship this year. We already have some prototypes that we will be sharing in the next couple of weeks. We have this server-side rendering story that is advancing quickly. And to make sure also that you can deploy your applications, we have been collaborating with Firebase, Netlify, Cloudflare, just to make sure you have a smooth deployment path. Netlify built a really intuitive deployment pipeline with Angular server-side rendering, pre-rendering, and client-side rendering recently. So I recommend you to have a look at it. All right, in the last couple of minutes, I just wanted to share with you some movements that have been happening in the community as well. So pretty happy to see that. It is a pretty good indicator that the work that we have been doing has been accepted positively by the community, and they have been building on top of it. Brandon Roberts built his analog.js meta framework, for instance. And in order to make Angular even more intuitive, he experimented with this single file component format in analog.js. That is very similar to what you'd see in Vue and Svelte. We're ourselves thinking of improving the authoring format of Angular further, but we are really cautious about it, just because we know that there are like hundreds of thousands of applications, there are millions of developers using Angular, and we want to make sure that we are more conservative in growing the authoring format and like shaping it over time. But if you have any thoughts and feedback about Brandon's authoring format, this will be really helpful for us as well. It could serve as an inspiration for our future work. Folks from the TanStack, they have been also helping us by implementing Angular support specifically for TanStack store and TanStack query. And with all this evolution that has been going on in Angular recently, we also wanted to reflect this into the brand of the framework as well. So we updated it a little bit, made it a little bit more hip over the past couple of months. We have been experimenting with different color schemes, and we landed on this. Together with a refresh of our documentation website that not only looks cooler, but it's also more helpful. We now have an interactive tutorial that uses StackBlitz web containers that you can have a look at today. All right, that's what we have built until this point. Next, we'll be working on quite a few other things, but just as a recap, partial hydration, making the signals perform fine-grained change detection, and iterating on the authoring format. This has been really a good fit for the goals that we have, making the framework more performant with better developer experience while also keeping it stable and reliable. Well, thank you very much for your attention. I hope the people without headphones were able also to hear anything, something that